Okay, this is the second part of Math 1630, Chapter 1, Section 1. We're picking up at Example 2, and we're going to continue from there and finish this section. Our example says for Part A that we need to find an equation in slope-intercept form for each one of these lines. And the information that we're given for the first one is that it will be through the point 0, -3, and it'll have slope of 3 over 4. The first thing to notice is that the point 0, -3 is actually the y-intercept. So that tells us that the -3 is actually the value of b in our slope-intercept form of the equation. And of course, we're given that the slope, which is m, is equal to 3/4. And so when we look at where these fit in, to the slope-intercept form of our equation, which is y equals mx plus b, this tells us that the value of m is going to be the 3/4, and the value of b is going to be the -3. So then, when we write this equation, what we're going to write is y equals 3 over 4 times x plus the value of b, which is the y value of the y-intercept, is -3. And then simplifying so that we're adding a negative is actually a subtraction operation. Then the equation of our line in slope-intercept form is y is equal to 3/4 x minus 3. Now in Part B of this example, we're asked to write the equation of a line again in slope-intercept form, which is going to be then the form y equals mx plus b. But we're not given the same information that we were given before. We're given the y-intercept. And while they call it y-intercept 2, that y-intercept, remember, is actually 0, 2. But the 2 gives us the value of b in the equation. So then we have to look at what is the other piece of information giving us? Well, the other piece of information we're given is that the x-intercept is 7. That means it crosses the x-axis at x equals 7. So the first part of that ordered pair is 7. And then because we're staying on the x-axis, we're not moving up or down, then the name of that point is 7, 0. Now with this information, we are well equipped to find the slope because we have 2 points. We have the point 7, 0, and we have the point 0, 2. And we recall that the slope is actually a quotient of those two differences. So that means then that our slope is going to be -2, and 7 minus 0 is 7. So our slope, m, is -2 over 7. So in our slope-intercept form over here, we will plug in for the slope -2 over 7. And then when we fill in with the rest of the equation information, we know that after the slope we have x plus the value of b, and that is equal to y. So the slope-intercept form then for our equation is y equals -2/7 times x plus 2. Now here in our third example, it says to find the slope of the line whose equation is 3x minus 4y is equal to 12. Now we can actually do this two different ways. So I'm going to show you both ways, and you can choose the one that seems to work the best for you. Method 1 is going to rearrange this standard form equation into the form y equals mx plus b. And in order to do that, we're going to take the original form of the equation, 3x minus 4y is equal to 12. And the first thing that we're going to do is we're going to try to isolate the term that contains the y, because we want y equals. So what that means then is we need to move 3x to the other side. And the way that we can move 3x to the other side is we can subtract 3x from both sides. And of course, when we subtract 3x on this side, 3x minus 3x will disappear, which is going to leave us with negative 4y is equal to 12, and then minus the 3x. And then because we want the y to be by itself, we want just y, not 4y, we need to move or remove the -4. And since it's -4 times y, the opposite of multiplication is division, so we will divide by -4. But that means that we have to divide everything in the equation by -4. So we accomplish what we set out to here. All we have left there is y. And y is equal to 12 over -4. 12 divided by -4 is -3. And here we have negative times negative, or negative over negative, actually becomes then positive 3 over 4 times x. And we're almost where we need to be. The only thing is we need to switch places with the x and the y. I'm sorry, with the x and the constant. And we will then have y equals the positive 3/4 x. And since the 3 is negative, that's the same. Oh, goodness. Sorry. Correct that. 3/4 x. And then because the 3 is negative, that's the same as saying subtract 3. So this is the equation, and this is the slope, because we know that this is y is equal to mx plus b, and that tells us that that value 3/4 is the value of the slope. Now, method 2 we know that slope is the difference of 2 points. We need to find 2 points on this equation. The easiest way to find 2 points on that equation is, first of all, let x equal 0. So if you have 3 times 0 minus 4y equals 12, and x is equal to 0, then that means actually what happens is 3 times 0 is 0. And what we have left remaining then is negative 4y equals 12, which tells us that y is equal to 12 divided by negative 4, and y is equal to 3. So that gives us the point 0, 3. And then by the same token, we can let x equal 0. Let y equal 0. Which means then our equation is 3 times x minus 4 times 0 is equal to 12. And just like we did before, 4 times 0 is just 0. And that tells us then that 3x is equal to 12. And x is 12 divided by 3. So that tells us that x is equal to 4. And that gives us the point 4, 0. And then from there, we'll simply use our slope method. The slope is equal to the difference quotient. And all we have to do is put in the points. I'll begin with 0, 3. And then I'll end with 4, 0. Remember that your x's go on the bottom, your y's go on top. And then 3 minus 0 is 3. And 0 minus 4 is negative 4. And I realized just now that I made an error, so we're going to go back and correct my error. Back up here, when I divide both sides by negative 4, that should have been y is equal to negative 3. So that means this point is 0, negative 3, and then that's 0, negative 3, which again makes this negative. And a negative 3 over a negative 4 gives us the same slope that we had before, 3 over 4. So there's your correct answer. So what we've learned about here is something called the point slope form. Comes from actually rearranging the value for the slope. You are not going to be required to use the point slope form, but this is, in case you should choose to use it, this is the point slope form of the equation. The best way to learn how to use that is to actually do a problem. So we're going to move to an example. In example 4, it says they want us to write the equation of a line that passes through the point 3, negative 7, and it has a slope of 5/4. This is what your point slope form looks like. It's y minus the other y point, or the y value, is equal to the slope, which is m, times the quantity, x, minus the x value of the given point. So in this case, our given point tells you that x sub 1 is 3, and y sub 1 is negative 7, and the slope is 5/4. So we will plug that information into the point slope form. So when we do that, we have y minus y1 is negative 7 is equal to the slope, which is 5/4, times the quantity x minus x sub 1 is equal to 3. And then we remove parentheses and simplify. So y minus a negative 7 is y plus 7 is equal to 5/4 times x is 5/4 x, and 5/4 times negative 3 is negative 5 times 3 is 15 over 4. And at this point we have a bunch of fractions to deal with, which is a little frustrating. So in order to not have to deal with those fractions, we're going to look at the denominator of those two fractions, and fortunately they're the same. So we're going to multiply both sides, or everything basically in the equation, by 4. So when we do that, this 4 cancels this 4. This 4 cancels this 4. And 4 times y is 4y. 4 times 7, remembering your distributive property, is 28, is equal to, now we have just 5x, minus, since we got rid of the 4's, 15. Now we're not quite done yet, but we're getting there. What we want to do now for our last step is we need 5x to come to this side, and we need the 28 to move to the other side. So if I subtract 28 from both sides, and then I subtract 5x from both sides, and that means I'll have to put a plus in between the negative 5x and the 4y, then I will now have an equation of the line. And that equation is negative 5x plus 4y is equal to negative 15 minus 28 is negative 43. And in standard form, that's the equation of that line. Now I want you to remember, we're going to do this example again, but we're going to do it using a slightly different method. So I want you to remember that that equation was negative 5x plus 4y was equal to negative 43. So just tuck that away in the back of your mind. And we're going to use the slope-intercept form. Remember, the slope-intercept form is y equals m, the slope, times x plus b. And believe it or not, we've got everything we need to know to be able to write the equation of that line, because we've got the slope and we also have x and we have y. So y is negative 7 and x is 3. The only thing we don't have is b. But if you have an equation where the only variable is a single variable, and that's b, then we can actually do a little arithmetic here and figure out what the equation is by looking first for the value of b. So what we're going to do is we're going to go ahead and say that negative 7 is equal to 5/4 times 3 is 5 times 3 is 15 over 4 plus b, and then we're going to subtract 15 over 4 from both sides. And of course, when we subtract 15 over 4 from this side, that's basically just going to take that away, and we're going to be left with just b. You're sitting there saying, but Miss Flint, I don't like fractions. Well, that's okay. Your calculator doesn't mind fractions a bit. So get your calculator and do the subtraction on your calculator. You enter in on your calculator on the home screen, negative 7, subtract, and then put your fraction in parentheses. Parentheses 15 divided by 4. Close the parentheses. Remember, you hit your math button and choose frac, and it says that's negative 43 over 4. So b is equal to negative 43 over 4. So you say that, okay, I know b, but what's the equation? Well, remember, we're going to go back and plug into y equals mx plus b. So the equation now is y is equal to the slope m, which is 5 over 4, times x, plus a negative 43 over 4 is the same as subtracting 43 over 4. And you say, but Miss Flint, that doesn't look like the other equation. Well, I understand it doesn't. But if you remember, take your common denominator and multiply everything by that common denominator. So I'll multiply 4 times y is equal to 4 times 5 over 4, leaves us with 5 times x. And multiplying this times 4, the 4's cancel. We have minus 43, and once again, all we have to do is move the 5 to the other side. And when we move the 5 to the other side, we're basically subtracting 5x from both sides. And again, we'll have negative 5x plus 4y is equal to negative 43. Now, I would suggest that you try both methods, see which one you like best, and then use that method every time. The reason that I choose to use this method so often is because that method only leaves me having to remember how to use one formula. I don't have to deal with an extra formula. But you can use the point-slope formula if you wish. So again, we have find an equation of the line through 5, 4, and negative 10, 2. And again, we can do this two different ways, but we're going to try the point-slope form first. So remember that your point-slope form is y minus y1 is equal to the slope times the quantity x minus x1. And using that method then, the first thing we need to figure out is we're given 2 points, we need a slope. And in order to find a slope when you're given 2 points, we simply follow our procedure of the difference quotient. The first point is 4, 5, and our second point is negative 10, negative 2. So our slope then is 5 minus negative 2, which is 7, because subtracting a negative 2 is adding a 2. And 4 minus negative 10 is 4 plus 10, which is 14. And when you put that in your calculator and change it to a completely different fraction by typing in 7 divided by 14, press your math key, and choose frac. When you hit enter, it will tell you that that's 1 over 2, or 1/2. So we know the slope is 1/2. Now, we can choose either one of those 2 points, whichever one we want, to be x1, y1. And arbitrarily, I'm just going to choose the first one because it comes first. So we have this information now. The slope is equal to 1/2. And the point x1, y1 gives us the values of x and y in the equation. So x1 is 5 and y1 is 4. And we're going to go straight back into this slope equation up here, this point slope formula. And we're going to write y minus y1 is 4 is equal to the slope, which is 1/2, times x minus x sub 1 is 5. And then the easiest way, really, we could say 1/2 x and 1/2 times 5, but I'm going to show you a way that might go a little faster for you. Rather than distribute, it would probably be just as well, since we know we're going to wind up with a common denominator, let's just get rid of the fraction now. So let's multiply both sides by 2. And when we multiply both sides by 2, 2 times y is 2y. 2 times negative 4 is negative 8. 2 times 1/2 gets rid of the 1/2 and leaves us with just 1. And since 1 times x minus 5 doesn't change anything, then 1 times x is just x, and 1 times minus 5 is minus 5. So we're almost where we want to go. We want to add 8 to both sides. And we want to subtract x from both sides. So on this side we have negative x plus 2y, and negative 8 minus 8 will disappear, equals x minus x will disappear. Negative 5 plus 8 is positive 3. And there is your equation. And I'm not going to keep doing them by 2 different methods. I'm going to let you make your own choice on that. There went my keyboard. So, example 6 is going to give us a horizontal line. And remember, the slope of a horizontal line is going to turn out to be 0, because we've already talked about that. So the thing is, we want to find the equation of the line through 8, negative 4, and negative 2, negative 4. So the first thing we're going to do is verify that this is, in fact, a horizontal line by saying, here's our slope formula. The first point is 8, negative 4. The second point is negative 2, negative 4. And negative 4 minus negative 4 is negative 4 plus 4, which is in fact 0. And 8 minus a negative 2 is 8 plus 2, which is 10. But 0 over 10 is still 0. So if the slope is 0, let's just use the point slope form to verify that this is actually a horizontal line. The point slope form says y minus y1 is equal to the slope, which is 0, times x minus x1. And just arbitrarily, let's just choose 8, negative 4 to be x1, y1. That means that this x1 is going to be 8, and this y1 is going to be negative 4. So we have y minus negative 4 is equal to 0 times x minus 8. So y minus negative 4 is y plus 4. 0 times x is 0. 0 times negative 8 is 0, which tells us that y plus 4 equals 0. And when we solve that by subtracting 4 from both sides so that we have only y, then this results in y equals negative 4. And that is in complete agreement with what we see here. The y value here is negative 4. The y value here is negative 4. So this equation, y equals negative 4, is the equation of a horizontal line. One, two, three, four. And over here we have the point negative 2, 4. And then on the other side we have the point 8, negative 4. So that is the horizontal line, y equals negative 4. Now we could have used the point slope form, even though we're going to come out with kind of an odd looking answer. We already know the answer that we're going to come out with here is y equals negative 4. Let's see if the point slope form makes it any easier. Point slope form, I'm sorry, point slope form is what I used. Slope intercept form. Slope intercept form will give us the same equation. Let's see if it gives us to us any faster. Y equals mx plus b. Again, we simply have to find the slope. And remember, the slope was 8, negative 4, negative 2, negative 4. We're dividing and we're taking differences. So negative 4 minus negative 4 is 0. 8 plus 2 is 10, but that gives us a slope of 0. And again, we can choose 8, negative 4 to be the x and y in the equation. So for y, I'm going to plug in negative 4. And for slope, I'm going to plug in 0. And for x, I'm going to plug in 8 plus b. So if I take that equation and I simplify it, since 0 times 8 is 0, negative 4 is equal to b. And then going back to my slope-intercept form, y equals mx plus b, y is equal to the slope, which is 0, times x plus b, and b is negative 4. And when I simplify that, 0 times x is still 0. Adding negative 4 is still negative 4. And I have y equals negative 4. So two very different forms of the equation of a line, two different methods for taking 2 points and finding the equation of the line that contains those 2 points, but we get the same answer either way. So you can choose whichever method you like the best, and you'll always know that you're going to get the right answer because both of the methods will always work. Key things to remember here are that horizontal lines are always going to have a slope of 0. Plotting the 2 points, giving them, and connecting them with a straight line, and this is the one that we were looking at just a few minutes ago. This is the line, the horizontal line, y equals negative 4, and there's your point, negative 2, negative 4, and 8, negative 4. Every horizontal line has a slope of 0. And the equation of the form of its equation is always going to be y is equal to k, and k is going to be the y value of the ordered pairs. So looking here, the y value of the ordered pairs is negative 4. So if k equals negative 4, then the form of our equation is going to be y equals negative 4. And we don't really even have to use either one of the methods we saw as long as you realize that your y values on your 2 points are the same. Now something similar is going to happen in this problem, except it's not going to be the y's. We want the equation of a line through 4, 3, and 4, negative 6. And again, we're going to try to find the slope first. So the slope tells us our first point is 4, 3. Our second point is 4, negative 6. 3 minus negative 6 is 3 plus 6, which is 9. But 4 minus 4 is 0. And you remember the cardinal rule, 9 cannot be divided by 0. Nothing, no matter what the number is, you cannot divide by 0. And so then we say that the slope is undefined. You have to remember that you never, 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 never divide by 0. Now, if the slope is undefined, when the slope was 0, we had a horizontal line. When the slope is positive, which means it's greater than 0, the line slants uphill. When the slope is negative, which means it's less than 0, the line slants downhill. Logically, there's only one thing left, and that is that the line doesn't go horizontal, uphill, or downhill. It just goes straight up and down. So this is an undefined slope, and it's called a vertical line. In this case, the only way to determine what the equation of that line is to consider what these 2 points look like when you graph them. So if I had a graph grid and I plotted 4, 3, 1, 2, 3, 4, 1, 2, 3. So here's 4, 3. And then I plot 4, negative 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. When I join those up, I'm going to see, well, it'll be nice if I actually got the line in the right place. This is harder to do than it looks on here, but I'm going to give it a shot. Then this is the line x equals 4. And you know it's x equals 4 because both of your x coordinates are 4. That's going to follow the same logic as what we did when we had a horizontal. Finding the equation of this vertical line means that you need to look at the fact that the x value in both is 4, and therefore the equation is going to be x equals 4, and that's going to be because the line is vertical. And one thing that I would really like for you to remember is that vertical lines, the equations of vertical lines are not functions, because we're going to talk about functions later on in this chapter. So when you only have an x, you don't have a function. You want to remember that later. So again, if you plotted those ordered pairs, 4, 3, 4, negative 6, you would see that your x coordinate in both cases was 4, and then that means that this is of the form x equals k, and k is determined by the x value of the points because that's what matches. So then your equation of your line is going to be x equals 4. So this is a summary of what we've learned about horizontal and vertical lines. We know that the slope of a horizontal line is 0. We know that the slope of a vertical line is undefined. We've learned that you do not say no slope. You never say that. We've also learned that there are different forms of the equations for lines. One of the forms is y equals mx plus b, which is called the slope-intercept form, and the slope is m and the y-intercept is b. We know that y minus y1 equals m times x minus x1 is what we call the point slope form, which has the slope of m and the line passes through this one point, x1, y1. Very importantly, we've learned that x equals k is a vertical line and it has undefined slope. It has no y-intercept except where k is equal to 0. So if you have the line x equals 0, what you have is the y-axis. And then alternatively, we have y equals k, which turns out to be a horizontal line. It'll have no x-intercept unless k is equal to 0. It has a slope of 0, and if k is equal to 0, you'll have the equation y equals 0, and y equals 0 is the equation of the x-axis. So at this point, we're going to look at an example problem of where you might use this realistically in an application. So we're going to first read the problem. In recent years, the percentage of the U.S. population 18 or older who smoked decreased, that's an important word, decreased, it's going to tell us something, at a roughly constant rate. Basically, it means that when you graph this, you're going to have a line that's going to travel downhill and it's going to be straight. That constant rate is what tells you that it's going to be straight. And this is the way that it worked. It went from 20.9% in 2005 to 18.1% in 2012. And we know that it decreased, so we know the slope is going to be negative. Now, what this has told us so far is that we have a set of ordered pairs. In 2005, that's the beginning point, they measured the rate of smoking and found it was 20.9%. And then in 2012, they measured again and found that it was 18.1%. So that gave us an ordered pair. That's going to be useful information to us because our first question says, find the linear equation that models the percentage of the population in any given year, basically. And then in part B, once we do that, we're told that one of the objectives of Healthy People 2020, which is a campaign of the U.S. Department of Health and Human Services, their goal is to reduce the percentage of U.S. adults who smoke to 12% or less by the year 2020. And we want to know, will they meet that objective? Now, we're going to take this one question at a time. So looking first at just question A, find an equation that describes the linear relationship. Okay, we've already established that we've got 2 points. We want to be careful how we define this, though, because I'm not sure we want to use big numbers like 2005 and 2012. So let's assume in this that 2005, we're going to set what's called a base year. So that we don't have to deal with such big numbers. And our base year is going to be 2000. So basically, the year in 2000, the X value for it is going to be 0. That's where we're going to start counting. That means that in 2005, X is going to be 5. That way we can not have to deal with 2005 and have to do arithmetic with such large numbers. And then in 2012, that means that X would be 12. It'll just simplify our arithmetic. So that means our 2 points are 5, 20.9, and 12, 18.1. And that's important because we have 2 points now, and if you have a linear relationship, that linear relationship is most easily described by y equals slope times x plus the y value of the y-intercept, y equals mx plus b. So the first thing we need to know then is the slope. So to find the slope, which is m, again, we're going to do the difference quotient. We're going to use the first point, 5, 20.9, 12, 18.1, or we could just as easily have used 12, 18.1, 5, 20.9. I keep emphasizing this because it's important that you realize that. All you have to do is keep your point coordinates together. So if I do it in this order, 20.9 minus 18.1 turns out to be 2.8. And 5 minus 12 is negative 7. And 2.8 divided by negative 7 is 0.4. And that's going to be a percentage, but it is the slope. 18.1 minus 20.9 is simply negative 2.8. And 12 minus 5 is positive 7. So we still get, and I'm sorry, I meant to put the negative sign here. So we still get negative 0.4. So there's our slope. And then we will use y equals mx plus b. And we need to find the y-intercept. So we can choose either point. I'm going to choose the smaller one. So x is going to be 5. Y is going to be 20.9. The slope is going to be negative 0.4 plus b. And negative 0.4 times 5 is, I believe, negative 2, but I will verify that. And it is indeed negative 2. And then here we still have 20.9. I think I'm running out of room. I need to rewrite this elsewhere. So let's get some more room here. And since we've already shown that both of these work, I'm just going to write what the slope is there. So again, our slope is negative 0.4. And when we do our slope equation, y is equal to the slope times x plus b. Using the first point, y is 20.9, is equal to negative 0.4 times x, which is 5, plus b. And that leads us to 20.9 is equal to, since we know that negative 0.4 times 5 is negative 2, and we want to actually move that over, I'm going to add 2 to both sides. And when I add 2 to negative 2, that's going to disappear and leave me with b. So we see here that 20.9 plus 2 is 22.9 is equal to b. So here's our equation. Y equals negative 0.4 times x plus 22.9. So remember that equation. Be sure you. And then I'm going to write it again here at the top of the page. So now we're ready to answer our question, will they reach their objective? Now, when we're talking about them reaching their objective, remember their objective is for the year 2020, and they want the percentage of people that smoke to be 12% or less. Well, in 2020, X is going to be 20. Because remember, our base year was 2000. So this is 20 years after 2000. So we take Y is equal to negative 0.4 times 20 plus 22.9. And negative 0.4 times 20 is negative 8. So Y is equal to negative 8 plus 22.9. And negative 8 plus 22.9 is 14.9. And what that means is 14.9% of adults in 2020 still smoke. And because 14.9% is greater than their desired goal of 12%, then the answer to do they meet their objective? And the answer is no, they don't meet their objective. Okay? Got a little bit further to go. This would actually work out better if we were in class to do this, but since we're not, you can also use the graphing calculator to fit an equation to the information and find the linear equation for 2 points, and then use that information to create a table of values and determine when the rate what the rate will be in 2020. This part of this, I'm just going to kind of like flip through it and tell you what I'm doing, but if you want this, you want to really understand this, I need to record this integrity and show you how to do that. So this is actually going to be a separate recording. So I'll actually I believe this is the last problem. No, I'm actually going to skip over this and pick up at example 11. And then I'll make a separate recording for example 10 where I can show you the graphing calculator. So let's wrap up by doing our example 11. Example 11 says to graph y equals negative 3/2 x plus 6. When we graph negative 3/2 x plus 6, what we want is we need a graph grid, which I don't happen to have on this. So I'm going to have to draw one. Graph paper works much better for this. Remember, the origin is here. When you're going to graph y equals negative 3/2 x plus 6, what you want to do is you first notice that plus 6 means that this is going to cross the y-axis at 0, 6. So we're going to have our x-axis, and this is our y-axis. We're going to start at the origin. We're not going to move back and forth at all because the first part of the intercept is 0. We're going to count up 1, 2, 3, 4, 5, 6. So that means our y-intercept is the point 0, 6. Then we're going to use the slope. And what the slope, -3/2, tells us is that we're from the point 0, 6, we're going to go down 3, and then we're going to go right 2. Because I kind of arbitrarily assign the negative sign always to the numerator when I'm going to use the slope to graph. So from 0, 6, I'm going to go down 1, 2, 3. Then I'm going to go right 1, 2. And that's going to put me right here. So when I went down 3, I went from 6 to 5, 4, 3. And then when I went right 2, then I went 0, 1, 2. So the coordinates of that point are 2, 3. Now alternatively, it would still work, but this is not usually the way it's done, even though it would still work. You can take -3/2 and say that that's 3 over -2, because both of those numbers are -3/2, both -3 over 2 and 3 over -2. If you're using 3 over -2, I want you to notice that what happens is, because the 3 is possible, you're going to go up 3. And then because the 2 is negative, you're going to go left 2. Now what happens if I do that? Well, if I go up 1, 2, 3, that means I'm now up here at 9. And when I go left 2, that's going to be 1, 2, which is going to put me at -2. So that point right there is 9, -2. But the key to this whole thing is that you need to remember, oh, now it's going to have a fit. You need to remember that if I draw a line through those points, it ought to contain all 3 of those points. So this is the line y equals -3/2 x plus 6. Now, despite that being a very sloppy explanation, I'm going to point out to you there's several ways to graph a line. One thing you can do is, as I said, you begin by knowing that your y-intercept is 0, 6. And now that I have a graph grid, this is going to be much easier to do. So from 0, 6, I'm going to go down 1, 2, 3, and right 1, 2, and that's going to put me at this point right here. That's the point 2, 3. If I were to go from there and go down again 1, 2, 3, and then right 1, 2, I would also have the point 4, 0. And having all 3 of these points makes it much easier to take a straight edge and draw your line, which gives us this line over here. You can also graph that line on the calculator. The key here to remember is that your slope is a fraction, and you should always put fractions in parentheses. And if it's a negative fraction, always put the negative on the outside. So your fraction is always going to be a division. So if I were going to graph this on the calculator, I would enter in negative, in parentheses, 3/2 x plus 6. Then I would press the zoom key, and I will go down and choose zoom standard, because zoom standard goes from -10 to +10 on the x-axis, and from -10 to +10 on the y-axis. And then I would just simply hit, well, actually, if you hit zoom and then choose the number 6, it's automatically going to show you that graph. And that will look very much like the graph that you drew by hand. I want you to be able to graph on the calculator, but also I want you to be able to graph by hand, and we'll do some practicing of that. Our last example is about tuition. And again, this is one that I am better served to show you how to do by actually showing you the calculator steps in class. So I'm not going to include it in this recording. I will do a separate recording, and I will have it posted before I see you the next time. So this is the end of this recording. Look for another one very shortly.